Hello, today we'll be discussing about the linear regression model for a time series data. Using the simple linear regression model, we'll be able to predict the future sales. To do so, we'll be needing one sample data, linear regression model package, and the pyplot package to display the predicted and actual values. In today's session, we'll have these 4 steps. We'll be loading a sample data. We'll derive a feature to use the sales 7 days ago, train a linear regression model, and predict. To start with, we'll be importing the required packages. We are here importing the NumPy and Matplotlib. And also, we are importing the data from PyDataset. This is an inbuilt package which has some sample data. From this dataset, we'll be using the BJ sales sample data. We have loaded the BJ sales data. To view the BJ sales data, the time is our independent variable and BJ sales is the dependent variable, which is the one we are going to predict. To find a new feature along with the time, we like to find it out what was the sales 7 days early. So if we stand on 8th day, which is 200, if we want to predict 200, I need to know what has happened 7 days ago. So 1, 2, 3, 4, 5, 6, 7. What has happened on first row, which is 201. If I know the sales on the first day, which is 200.1, and if I know the time at 8th, I'll be able to predict the value of 200. Similarly, to predict the value of 200.3, I need to know the value 199.5 and the time as 9. At point 1.2, we're shifting the sales data by 7 and we'll be able to get the data similar to this. We observe that on 8th row, the new feature sales lag 7 has a value of 201, which is nothing but the sales value at the first row. And similarly, the entire data has been shifted by 7 rows. If we want to see only the header part of the data, we see that all of the head of the data sales lag 7 is not a number. It is an invalid numerical value. We'll replace it, but before that, let us view some of the data from the bottom of the data set. Now, to remove the NaN data from this data set, we'll be filling the data from whatever available the next row. This is called backward filling. We'll be taking this value 200.1 and then fill all the NaN values by 201. Let us perform this command and we see that 201 has been populated in all the NaN values. It depends whether we'll be using backfill or forward fill, or whether we'll be replacing the NaN value with a fixed value called 0 or any other values. In our example, we'll be taking this backfill, which is much more logical. At the step 3.1, we'll be loading the linear regressions package, and this has been taken from the sklearn. In this step, model equal to linear regression, we are creating an object model of linear regression class type. Here, we want to segregate the dependent values, which are time and sales lag 7, populated with X, and the dependent value, which is sell, to Y. This is the value which we are trying to predict with the help of X. Let us view the shape of X and shape of Y. In the next step, we will be converting the shape of X and Y, which is required as part of the input requirement of this linear regression. X and Y should be in matrix form, and they should have 2 dimensions. Now if we see, the shape of Y is 150 and 1, so it has 150 rows and 1 column. We'll be able to see the values, first few values of Y, and similarly we can view the shape of X, which is 150 and 2. In the next step, 3.2, we're populating the values for the trained and test data. From first row to 120th row, from the 0th row to 120 records will be considered as the trained data, and rest of the data will be considered the test data. We'll be using this trained data to train our linear regression model, which is model equal to linear regression fit functions. We are passing X train and Y train. Our model has been trained and want to view the intercept, which is 31.707, and the coefficients are 0.1 and 0.8. We have 2 coefficients for 2 independent variables. One is for time and the second one is for sales lag 7. We'll be running these equations for all the records. Please note, while predicting the value of Y, we're passing the entire X. It has train and test data together. The first 120 records are trained and the remaining are test data. We can view first few records of the Y predict. We can also pass it from 0 and then view from the first row. In section 4.2, we'll be visualizing the data. The first plot is to visualize the actual data for all 150 records. The second row is to visualize only the trained data, which is 120 records and its 120 predicted values. It will be colored as blue. And the third plot will be for the test data, and the Y predicted value from 120th to 150, and it will be colored as red. Here we can view the plot. The green color line is for the actual sales data. The blue color line is the predicted values of all the trained data. Remember, we have taken the first 120 records for our trained data, and the blue line is up to 120 records. And the red color line is for predicted data for the test records. This is the data which is not known by the model. X-axis represents the time and Y-axis represents the sales value. In 4.3 paragraph, we are trying to predict a future values which is beyond 150. We'll be populating the X values from 151 to 165. Here I have mentioned 166, and the numpy A range functions will create a sequence from 151 to 165. Let us view those values. We got those X values. In this for loop, we are taking each of the values of I, which is 151, 152, 153, and so on. For example, in the first case, we take 151, and then we take the value which is in the 8th position from behind. You remember from our previous commands where we were lagging the data for 7 steps. So on 8th day, we'll be able to take the data of the first day. And similarly, when we are predicting for 151, we need to go back 8th step to get the data for predicting the data of I. We are predicting the value of Y and concatenating it with the main Y predict. Similarly, we are taking the value of X and concatenating it with the main X. We have run this code and I want to view few values of X. We'll be able to see the values of X. For example, so 151, we got the values here, X. Now to plot the values, we want to color all the values which is from 151. And that's why we have written this list comprehension, which is one of the Python's syntax to populate the elements of a list. It will be blue if it is less than equal to 150, otherwise it will be red, and it will run through from the entire value of X, entire X array. In step 4.4, we'll be visualizing the entire data. We'll be visualizing the actual values. We'll be visualizing the value which has been predicted from the trained data, the value which has been predicted from the test data, and extrapolated predictions. Here is our final plot. Here we can see the green color as an actual values. The blue color is the predicted value of the trained data. The red color is the predicted value of the test data, and the orange color is the extrapolated values, which we extrapolated for 2 weeks beyond 150th day. And that's all for today.